How are you guys?
I'm great.
Good. Glad to hear it. I have chapter 1 tests that I can pass back. I know it's been a long time. While I'm passing these back, I want to let everybody know that I've also put the answers on, or the answer key up on the content library. So if you wanted to check what the answers were, they are there. Today, we're going to start with taking questions from the last, or from the previous one.
I'm proud of myself now.
Grace, which one is Grace? Grace. I'm still working on it. We don't see anything, so I haven't figured out.
Yeah. What? No. Which
Times.
one?
You guys are. Remember, you guys were playing tricks on. So, congratulations.
There's not one.
Okay. So again, the tests have been passed back, so feel free to kind of look through things on the answer key on your own time. It's up in the content library, so I'll let you guys look that over and think about it or whatever if you want to. Today, I'd like to start with homework questions. So if you guys have anything from 3.1 or 3.3, I'd be happy to kind of address those things. Anthony? Sure. Does anybody have a preference on which one? 7? Sure. Okay. Oh, my goodness. So, first thing I'd want to do is I would do some rearranging of this so that the x's and y's and you need to be able to see what it is I'm doing too. First thing I would do is change my projection so you guys can see what it is that I'm doing. There we go. 4x to both sides and then subtract 9 from. And then from the second equation, I'm going to subtract 9y from both sides. So there's my new system. So far, so good, Anthony? Okay. So now I'm going to pick a variable to eliminate. I can either choose to eliminate the x's or the y's. It doesn't really make much difference here. For the sake of argument, let's say we eliminate the x's. So to do that, I'm going to multiply the first equation by 11 and the second equation by 4. So the coefficients on my x will be negative 44 and positive 44. So I'll do 11 times A plus 4 times B It's going to give me 44x plus 55y equals negative 99. And then this one I'm multiplying by, equation B I'm multiplying by 4, so it's going to be negative 44x minus 36y equals negative 80. So when I add down, I get, what is that? That's positive 9y equals negative 179. I don't know if that's divisible or not. Seems to not be. Did I make a goof up somewhere with my negative signs or anything? I don't think so. Everybody, did I make a mistake? Did anybody see a mistake? Before I keep these nasty fractions. Oh, 19. That's much better. Still doesn't, well, it doesn't make much difference. Still a crummy fraction. So far, so good. Okay. And then to find my solution then for x, I'm just going to plug this y in someplace. I think the easiest place to plug in would be right here into equation A, since the negative 4x is already by itself. So that's 5 times negative 179 is negative 895 over 19. And if I make a common denominator with 9 and 895 over 19, that's 171 over 19. So I'll just repeat. So that's going to give me, when I combine those, negative 174. And when I multiply both sides by negative 1/4, that gives me 181 over 19 for x. But that doesn't seem, I mean, that seems right. Let's just real quick check that out on my solver and make sure that that is indeed the correct answer. Unless somebody sees an obvious mistake anywhere. And I'm always open. Do you see one? No. That is correct. So, just a yucky answer. But we did it right. What's the way you can check this, even if you get a yucky answer like this, to know if you're correct or not? Yeah, just plug them back into the original, both the x and y, and make sure it satisfies both equations. That's all I did to check this. I just did it real quick on my calculator. But those do satisfy, so. Does that feel better, Anthony? Okay. Anybody else? John? Sure. Did you not like the fractions? Okay. Well, then let's get rid of them. So in equation A, I might just start by multiplying it by 7. Now it looks a lot nicer, right? So now I'll just rearrange things to get the x's and y's all in the lining up, just like I did in the previous one. So I'm going to subtract 5y over, 5 over for equation A, and then subtract 5x over for equation B. And now it doesn't look so bad, right? So I'm going to eliminate the y's this time because the numbers are smaller that are involved. So I'll do 2 times equation A plus 5 times equation B. So negative 22x minus 10y is equal to 10. And then I'm going to have negative 25x plus 10y is equal to 35. Add down. So that gives me negative 47x equals 45. So x is equal to negative 45 over 47. And then to get my y, I'm just going to plug that back in. So the place I would plug it into is here, into equation B. But it doesn't really matter. So 5 times 45 is 225. And let's make a common denominator with the 7. 7 times 47 is 329. So 329 minus 225 is 104. And if I multiply by 1/2, I just get 52 out of 47. And again, let me run the checker here real quick to make sure that that's right, but probably is. Is that what you guys got? Nobody wants to answer that. I don't know if it's because you were scared or because you didn't do it yet, but that's what you should have gotten. Is that okay? So again, if you don't like the coefficients, well, you just multiply through to change them into something that's easier to deal with, right? So that one we did like 2 steps in multiplication just because the fractions were, well, they're not real convenient, right? So turn them into something more convenient. No big deal. It's a good trick to know, right? Maybe you wouldn't have thought of it, but now that you've seen it, that probably goes to the top of your old tool chest there as something that's pretty handy. Any other homework questions? Ella? Sure. Homework 1, number 5. Now this is probably going to be kind of tough to do on OneNote and get a good straight line out of this, but we'll do our best. So for the first one, let's make our XY table. So I'll pick X to be 0 and Y can be 1. And then maybe I'll pick X to be 5 and then y would be -9. Okay with that? And then the other one I'll do in green. It'll be like Christmas colors here with red and green. So you could rearrange b, but you don't have to. So if I don't bother to rearrange it, if x is -2, that gives me a -6, which means y would have to be 0. Okay with that? And then if x is 0, y would have to be +6. So there's some points there. Again, if you wanted to rearrange it and put it into slope-intercept form and pick x's and y's that way, that's fine. But if it's in that x and y on the same side, you can just pick one or the other to be 0 and then figure out the other one. It's usually pretty easy to do that way too. All right, so I have 0, 1, and then 5. Oops, I shouldn't have picked something so big, huh? Because I only can go up to, I don't have -9 on there. I'm going to retract here. How come you didn't yell at me before? Let's do 4, and that'll give me -7. So that'll be like right about there, maybe. That's kind of straight. There's a ruler there. How do I do that? This thing? I wish I knew how to do that. Insert. That doesn't look promising. Home. That doesn't look promising. Yeah! That's what I'm talking about. Thank you. Ruler. That doesn't seem like that's really giving me what I want. Well, that's something. Well, we'll explore more with it later. I don't know. If you figure it out, please tell us. We'll have a little lesson and you can tell us what to do. So that looks like it was something in there. So maybe x is -1 and y is equal to 3. Let's see, did that work? Satisfies the first one. Oops. Satisfies the second one. That must have been it. Ella, are you happy with that? Okay. So I did my best to do it on OneNote. I did okay. Little helpful tip when you're doing this by hand. The further apart you pick your points, usually the more practically, or the better result you get it from a practical purpose. Because if you pick them really close together and you're a little tiny bit off, it makes it a lot off later on. If you pick your points really far apart, if they're only a little off, it's still only going to be a little off. So if you're trying to do this by hand, the further apart you pick your points, usually the better result you get. And when I say pick your points, I mean like when you pick your x's here. Sure. So you just read the point off. It looks like it's -1, 3. That's it. X equals -1, y equals 3. That's all you had to do. That's okay. Again, we're just reinforcing the idea that the intersection is the same thing as the solution to the system, right? Cool? Okay. Last call on homework questions? Okie dokie. So we're going to do 2a. Is first thing we're going to talk about is solving systems of linear inequalities in two variables. So when we do this, we're only going to use graphing to do it. Actually, let's do that. Okay. So the first thing I would do here is I would rewrite both the equations so they're in slope-intercept form. Now, I didn't bother to do that when we graphed before, right, Ella? But I am going to do that now. The reason that I'm going to do that now is because I need to know what the inequality is going to look like when it's in slope-intercept form, because they could switch directions on me, and that matters a lot. So I'll start by subtracting 2x from x, and then dividing both sides by -1. So when I do that, the inequality is going to switch directions. Oh, poopy. I'm stupid. Let's do that. I didn't want them to be parallel. Okay there? All right. So I'm going to make a xy table for y equals 2x minus 5. So that's like 0, -5, and then 2, -1. So I just picked some x's and figured out their y's, right? Did it matter what x's I picked? Not at all. Any x's are fine. And then I'll graph or make an xy table for y equals 3x plus 1. So I'll pick x to be 0 and then x to be 3. Again, I try to pick them a little bit further apart so that when I draw my line, it tends to be a little bit more accurate. But that's just personal preference. You don't need to do that. Okay. So now I'm going to go ahead and draw my lines here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 1, 2. Okay. So the red one, I have 0, -5, and I have 2, -1. And I'm going to go back now and look at my inequality. So it's a strict less than. So what kind of line should I draw? Should it be solid or dashed? Should be dashed. Okay. And should I be shading above or below? below, right? Because it's a less than. Same rule as before. Now let's draw the green. So I have 0, 1, and then 3, 10. Oops. And this one is a less than or equal to. Right? Yeah. So which way should I be shading the green one? Below. So what does my solution look like? It's the intersection of the shading. So it'd be like this area here, where both the red shading and the green shading overlap. So keep in mind, like if I extend this out, oops. There's like red shading in here that isn't part of the solution, right? You guys get what I mean? And then there's this green shading like up in here that's not part of the solution. It's just the overlap of the two areas. Does that feel okay? Can I get no solution for this?
Yes.
Yes, what would it look like? Perfect, yeah. If the shading doesn't overlap, then there's no solution. Can I get all real numbers as a solution? No, right? There's no way that the whole XY plane gets shaded by both lines, right? Everybody agree with that? Now, it's always going to be some region inside the XY plane. There's always going to be infinitely many solutions, right? Because like any point in here, like this point satisfies both inequalities. It's not just the intersection that we care about. It's any point, because an inequality is like a less than or greater than. So there's lots of points that will satisfy that, right? So it's always going to be a region of infinitely many points. So our answer is always going to be a graph. Unless it's a situation where there's no solution, but that probably wouldn't be obvious to you unless you drew the graph anyways, right? Do you think we're okay with that idea? These should be pretty easy to deal with, right? You're just plotting two lines and then shading either above or below respectively and shading the intersection. Now, when I did this one, I shaded both intersections. You don't really need to do, or shaded both regions. You don't need to do that on yours. If you just want to shade where the overlap is, that's perfectly fine. Is everybody okay with that idea? Okay. So that should be fine, right? No big deal. We've already done some graphing of inequalities. All the rules for handling the inequalities is the same. And you're just graphing a line, which is easier than an absolute value. So shouldn't be too big of a deal. You guys agree? That's okay? All right. So the next thing that we're going to do is we're going to solve some three variable linear systems. And to do this, we're going to just use substitution and elimination like we've done before. But they get a little bit more complicated because we have three variables and three equations now. So let's just kind of walk through, and we'll talk a little bit about the process or what the goal is once as we're kind of doing the example. Since we've already kind of know how to do elimination substitution, we're just generalizing it to a more something, to a broader context. So just as a heads up here, when I'm writing the variable z, I'm always going to put the bar through the middle of it, because I acknowledge that my z's and my 2's look almost identical without it. So just keep that in mind, that my z's have the bar through the middle, my 2's do not. Right? If you get rid of the bar, could you tell the difference that one's a 2 and one's a z? No way, Jose. My suggestion to you is to do the same. It's very, very easy once we start getting z's in there to get confused as to what's a 2 and what's a z. Even in your own work. I know you're like, yeah, that wouldn't happen to me. I'm like, it could happen to you. I'm just letting you know. That's a suggestion. You don't have to do it. That is a 19, yes. Okay. So the idea here is we're going to have to do several eliminations. We're going to take this 3-variable system and we're going to break it down into two variable equations that we'll then do another elimination on to make one variable equation. Okay with that? So we're going to have to do 3 eliminations. One elimination to get one 2-variable equation, one elimination to get the other 2-variable equation, and then one more elimination to get a 1-variable equation. So that's the process that we're going to use. When we make our two 2-variable equations, you have to eliminate the same variable each time. You can't have one equation with x and y and the other equation with y and z, because you won't ever be able to get a 1-variable equation out of those two. If this one has x and y in it, the other one needs to have x and y in it. So you have to eliminate the same variable the first time from each of the two. Everybody okay with that? So the way I like to think about it is I like to pick one of my equations to act as like my eliminator equation, where I'm going to use that equation to eliminate, the variable that I've chosen from the other two. So if I look at this, the easiest variable that it appears for elimination is going to be the y's. Because I can just add equation C to equation A to get rid of the y's. And then I can add equation C to B to get rid of the y's. Do I have to do it that way? No. There's lots of different ways you could have gone. You could have eliminated x first. You could have eliminated z first. You could have done different things to eliminate x and z. It doesn't really matter. You just have to pick one variable to eliminate first. My suggestion to you is take a look at it and see which one looks like the easiest one to eliminate and do that. So I'm going to do a plus c and then b plus c. Oops. So that's equation A, and then equation C is that. I have equation B, and then I have equation C, which is that. So something unusual is going to happen here when I add A and C together. What do you notice that happens here? Yeah, I cancel out two variables. Does that happen every time? No, that's a rather rare occurrence, but it's a welcome occurrence because we're able to solve for Z now immediately. So we're actually not going to need to make a two-variable system here, which is cool, right? If I take the other pair, if I add B and C together, I get 5x plus 3z is equal to -1. So now I can solve for x by just substituting z in. Usually at this step we'd be making solving a two-variable system now, just like you did last night. But since we got two variables to eliminate, cool, that doesn't happen very often, but if it does, yay for us. We can go and skip having to make the two-variable system and go straight to solving for another variable. So when I subtract 9 from both sides and then divide by 5, I get -2. And now I have two answers, right? To get the third answer, all I'm going to do is plug those back into one of our original equations. I'm going to choose to use equation C because the y is positive there, so I can't screw up an extra negative sign. So when I have 5y minus 5 equals -20, if I add the 5 over, I have 5y equals -15. If I divide by 5, I get -3. So the way I'd write my answer is -2, -3, +3. I'm always going to write my answer alphabetically, so x, y, z. Okay with that? Let's solve the same one using substitution to see what the difference is. And then you guys can, after that, we can make a decision about what we think is going to be the best thing to do. Oops, I didn't really need to do that. Okay. So the idea here is we're going to pick one equation and one variable to isolate. We're going to then plug that variable back into the other two, simplify down to make a two-variable system. We'll pick one of those two variables or one of the two equations and isolate one variable from those, and then plug it back into the other one, and that'll give us our answer, basically. So here we have to do two substitutions. Everybody okay with, or three substitutions, I should say. So if I look at this, it appears the easiest thing to use would be to get the x by itself in equation C. And then we're going to plug that back into equations A and B. Is everybody okay there? So now I'm going to go ahead and distribute things through. So the first thing I'm going to do is distribute that negative. And here I'm going to distribute that 4 through. And now what do you notice has happened in that first substitution? When we go to combine like terms, something great has happened again, just like it did when we did the elimination. Yeah, I have a 5y and a negative 5y, so when I combine like terms, I have no more y's. Does that usually happen? No. But it happened this time, which is fantastic for us because it saves us having to do another step. So if I do the same combining down here, I have minus 25y plus 8z minus 80 equals 19. So I can now solve for z directly. So I'll subtract 20 from both sides, giving me negative 6z equals negative 18. And when I divide by negative 6, I get z is equal to 3. Here, if I add 80 to both sides, and then I plug in 3 for z, if I subtract 24 from both sides and then divide by negative 25, I get that y is equal to negative 3. And now, since I have x and z, y and z, I can plug in back here. So what do I get here? I get 15 plus 3 minus 20, which is negative 2. So again, I'd have negative 2, negative 3, positive 3. Which one of those two feels easier to you? I'll tell you my answer is elimination feels much easier, right? Yeah. The number stays smaller. There's less things going around. There's less symbols. The advantage of elimination is each time you do an elimination, things get smaller. You have less stuff rattling around. The drawback to the substitution is every time you make a substitution, the equation gets longer before it gets shorter. You know what I mean? I think elimination is by far the easier as you get more complexity. Things, I think, tend to get easier rather than more difficult. Should we do another example? Let's do another, and then we'll be done. Sound good? Excuse me. Okay. So I'm going to name these three equations A, B, and C. Let's pick a variable to eliminate. Is there any obvious, easy choice here? Ella? Sure, that's as good a reason as any. It's not an outstanding option, but at least you have the negative already in place for it. So let's do that. So let's use the A, eliminate the A's first. So to do that, obviously Ella says that we can add B and C to eliminate the A. And then what other combination are we going to do? So we've done B and C, so either we can do A and B or C and A. It doesn't really matter. I would do C and A because I already have the negative sign for C. So to get them to eliminate, I'd have to do 4 times A and then 5 times C. Everybody agree that? That'll give me 20x and negative 20x, so they'll cancel out. All right. So for B plus C, because nothing changed, I'm not going to write them down again. I'm just going to write their sum down. Is everybody okay there? So I get 6B plus 6C equals 3. Here, because I actually did something, I'm going to write it out again. Um, 35, right? Is everybody okay there? I'm going to refer to this as equation D, and this one as equation E, because these two now are going to make a new 2-variable system. Is everybody okay there? Now we should choose to eliminate either the B or the C. Does it make a difference here? Since they're exactly the same, obviously no one is easier than the other. So what is the common multiple between 6 and 35? Well, it's just going to be 6 times 35, right? That's as good as we can do. So we're going to do 35 times D plus negative 5 times E, or I'm sorry, negative 6. You could have put the negative sign on the other one. It doesn't really matter. Everybody's okay there, though? 35 times 6 is 210, I think. And 3 times 35 is 105. And then negative 6 times 35 is negative 210. So what would I say here? Yes? No. I wrote, yeah. Yes, thank you. So those should be C's. That's what you're saying, right? Yes. Yes, yes, yes. Nope, that's absolutely right. I made a boo-boo. Okay, so what do I conclude here? No solution, right? Does that usually happen? No, not usually. Usually we're left with like a variable still there that we'd have to solve for and then do the back substitution. But no solution can happen. That's perfectly fine. And it can happen at this step, or sometimes if we're lucky, happen at one of these steps. That can happen sometimes too. It's better if it happens there because it saves us a lot of work, but it doesn't always have to. Is everybody okay there? Okay. I want to give you guys some time to work here in class, so we still have 20